Allahumma sholli ala sayyidina Muhammad abdika rasulika nabil ummi wa ala alihi washabihi wa barik wasallam amma ba'du. Kami ucapkan selamat pagi, salam sejahtera untuk kita semua kepada para partisipan yang telah kami undang ya. Kemudian terima kasih atas kehadiran Bapak Ibu semua yang telah menyempatkan diri dalam kesibukan waktunya untuk bisa bergabung dalam acara webinar Robotic Inspection yang diadakan oleh PT Pratita Pramanugraha dan bekerjasama dengan Baker Hughes WG Teknologi sebagai prinsipal kita dengan mengambil tema Robotic Inspection in Combating Convenience Space Entry. Kemudian pada kesempatan kali ini, izinkan saya Rizal akan memandu jalannya acara webinar kali ini hingga selesai. Alhamdulillah telah hadir bersama kita sekitar 80 partisipan dari berbagai perusahaan dan juga dari berbagai line industri. Terima kasih sekali lagi atas kehadirannya untuk Bapak Ibu sekalian. Kemudian pada acara webinar hari ini, para partisipan atau peserta nantinya akan mendapatkan sebuah e-sertifikat sebagai bentuk apresiasi kami terhadap kehadiran Bapak Ibu semuanya. Dan tentunya di akhir acara, seperti yang diinfokan dalam undangan webinar ini, bagi peserta yang beruntung mendapatkan gift atau door prize yang sangat menarik persembahan dari PT Pratita Pramanugraha. Kemudian Bapak Ibu sekalian, boleh saya lihat responnya ya dari partisipan yang sudah hadir saat ini untuk menekan tombol emoji atau raise hand ya. Oke, apa kabar Bapak Ibu sekalian? Silakan Pak. Oke. Sudah hadir semua ya. Nah, kemudian untuk rundown acara, sebelum kita masuk ke acara utama, izinkan saya sampaikan rundown acara kita hari ini. Ya mungkin Pak Arif bisa bantu tampilkan untuk rundown-nya Pak. Ya, bisa dimunculkan Pak rundown-nya Pak. Ya, oke. Untuk rundown-nya mungkin saya bacakan ya. Yang pertama adalah pembukaan, ya. Kemudian selanjutnya adalah pemaparan materi yang akan disampaikan oleh Muhammad Syafiq, Service Sales Manager WG Teknologi. Ya, beliau memulai karirnya sebagai inspection engineer dengan pengalaman lebih dari 10 tahun di industri oil and gas. Nah, dan nantinya di akhir materi kami meminta kesediaannya untuk mengisi polling dari Bapak Ibu sekalian ya untuk memberikan feedback dalam sebuah polling yang akan muncul di layar Bapak Ibu sekalian semuanya. Nah, dan pada sisi tanya jawab akan dibantu oleh Pak Arif Mumba. Beliau saat ini adalah sebagai penanggung jawab divisi teknikal dan beberapa metode NDT di lingkungan PT Pratita Pramanugraha. Kemudian persembahan dari kami lagi untuk 10 penanya terbaik akan mendapatkan gift. Dipersilakan kepada para peserta atau partisipan yang akan nantinya mengajukan pertanyaan di kolom Q&A selama materi disampaikan. Nah, oke, sepertinya Bapak Ibu sekalian sudah tidak sabar ya untuk mempersingkat waktu. Mari kita langsung saja mendengarkan materi yang disampaikan oleh Syafiq. So Syafiq, I'm in place, are you? Okay.
Hello, Assalamualaikum, and very good morning to everyone. First of all, I would like to say thank you for joining this session, and thank you to Pratita for organizing this webinar session, and also to the customers, to our partners, and to attendees who join this session. Let me share my screen. Let me know if you can see my screen.
Yes, we already see.
Okay, perfect. Right, my name is Muhammad Syafiq. I'm the Robotics Services Manager for Waygate Technologies, a Baker Hughes business. Waygate, actually, we concentrate on building the robotics because we want to address the customer business pain points when involve confined space entry, eliminate associated costs that relates to sending people in, scaffolding erection, dismantle, and also we want to reduce HSE risk. So this robotics, we have 4 kind of robotics fleet. As you can see on the screen, from the left is fast RBI platform. It's designed for large application, large assets, large sphere, or large tanks. Next to it is PTV HD30. It can be standalone robotic camera, or it can be on board the fast RBI to get the full HD image or videos. Next to it, the ultra mobile robotic crawler. I would say the famous crawler that we have, the bike. It is multimodal robotic carrier on board multiple sensors. It equipped with 3D lock. It's like GPS, where it can help the inspector locate the robot inside the asset. Last but not least,
maybe you can full the screen, the presentation.
I'm sorry?
Full screen. You slides presentations. You make the slide presentation.
Okay, let me try again.
Yes. Okay, then you can make the slideshow.
Hold on, Did I share it?
Okay, already come. And make it a slideshow.
Okay, it's full screen now?
No, not yet.
I think, Shafi, what you can do, you just press on the button on, the icon looks like the book. That will actually change the slide to the full view. The reading mode.
Okay, already comes, Shafi. You can. Okay, that's good.
Correct?
Yeah.
Okay, sorry for that. Okay, yeah, we have this kind of 4 robotics fleet in our robotics program. Yeah, we want to again, eliminate confined space, reduce costs, and also reduce ASC risk. A brief introduction about who we are and what we used to be. Yeah, we are more focused on the building the non-destructive testing equipment and services. We have more than 135 years of experience in NDT. Our aim is to provide peace of mind to our customers in order to ensuring the safety, quality, and also productivity. We used to be GE Special Robotics, and now we are fully converted to Waygate Technologies.
Oke, Bapak-Bapak, Ibu semua, ya, sambil saya menerangkan. Jadi Muhammad Syafiq ini adalah service dari Robotics, ya, dari Baker Hughes GE Waygate Technology. Kita sekarang akan presentasikan untuk aplikasi robotik di conference space, ya, di ruangan tertutup, ya. Jadi nanti mungkin Bapak Ibu kalau misalnya ada yang mau bertanya, tinggal klik kolom QA di bawah, ya, mungkin nanti bisa ditanyakan langsung, ya, di chat di situ, ditulis di situ, nanti kita bisa akan jawab langsung dengan Syafiq. Okay, please go ahead, Syafiq.
Okay, now these are our solutions that we believe can address our customer business pain points. The products ranging from hardware, software to services, and also a complete solution package for every industrial application. If you see here, we have software that we integrate into our equipment, and then the services that we offer to the customers. So we have X-ray, computed tomography, field radiography, digital RT, eddy current equipment, instrument and probes. And for robotics, it is under the RVI, remote visual inspection, and also together with our boroscope business. And for ultrasonic testing, we have thickness gauge, phase array, gravity floor, and also PCM. Now let's have a look on how our robotics solution can assist our customers in terms of eliminating human entry into confined space, reduce accessibility that related to cost, such as scaffolding erection, rope access, confined space procedures, and how we minimize the exposure of workers to hazardous or toxic environment. In the next slide, I will play the video.
Despite modern safety protocols for vessel inspections, all it takes is a few minutes for things to go from bad to worse. So we asked ourselves, how can we keep you safe while meeting applicable API codes? How can we save you time? How can we make inspections better? With robotic vessel inspection solutions from Waygate Technologies. Simple full picture without having to put yourself at risk using the PTZ HD30. This powerful industrial-grade camera provides full HD image and LED illumination. Combined with a 3D lock hole, you'll get full 3D spatial awareness as well as 3D interactive camera control. And rather than twisting and pulling a pole up and down, the 3D lock hole positions the camera to the area of interest with a single click, while movement and image collection can be fully pre-programmed. For superior NDT inspections, navigate every inch of confined space with the bike. The only magnetically wheeled robot capable of maneuvering in even the most complex environments. There is no need for rope access or scaffolding for those hard-to-reach spaces. With modules to collect ultrasonic, eddy current, video probe, or structure light NDT data. With 3D lock software, all inspection data is automatically tagged with a precise position inside the asset, while a digital twin containing all the inspection data is maintained. Entry into confined spaces no longer needs to be a major risk to the safety and health of those involved in operations, thanks to robotic vessel inspection solutions from Waygate Technologies. With the bike, PTZ HD30, 3D lock hole, and 3D lock software, you can increase safety while ensuring more accurate, consistent, and efficient inspections.
Okay, I hope you enjoy the video. Now let's go to the data that I got for oil and gas in terms of confined space risks or fatalities. If you ask me what kind of the industrial jobs that dangerous, I would say is industrial inspection, because inspection work is dull, dirty, and quite dangerous, especially if it's involved confined space entry. Now, lots of inspection activities involve confined space entry and expose a human to hazardous environment, in particular when the job combine working at height, but perform cleaning or perform the NDT. This is exactly the environment which confined space is conducted. Typically, the inspection and the cleaning process involve the confined space entry, with all the associated time and cost. If you have manual inspection, both visual or UT by an inspector holding a sensor with concern of repeatability result, so there will be an issue because I was an inspector going inside the confined space. Yep, sometimes I did mistake. I forgot what the reading that I took. And now I realize that when we're having these solutions, we can eliminate those kind of mistakes. If we talk about cleaning or handheld water jet, this kind of activities also involve hazardous activity by itself, and also scaffolding erection and dismantling to reach the accessible areas is also contributing to HSE risk. Now, these days, robotics are becoming more integrated part of the inspection process by allowing for increased inspection safety, to get more efficient, high quality inspection data. With robotic also, we can have the ability to pre-plan inspection beforehand with the applicable codes and standard practice. And also we can have the simulation, and then by having the 3D localization, we can map all the collected data within a 3D model. So easy for inspector to know where the robot located inside the asset, and for customers to know where are the defects located inside the asset. And this kind of advancement of technology is a path forward for the advanced inspection robotics. Now, let's go to the first robotic crawler that we have, the bike. The bike platform is a multi-purpose inspection robot. The size and the payload capacity and its innovative, we call it locomotion concept, will allow bike climbing obstacles such as stairs or 90-degree transition. The bike also equipped with the integrated navigation camera, the TZ1 camera, and also 3D dimensional position sensor or the 3D lock. It will help the operator get precise information about the robot position even in complex environments. The robot is an inspection tool that can carry multiple sensor packages simultaneously. So if the customer want to tailor-make their sensors to the bike, we are open for discussion. And by having this, the bike is like a Lego where we can pick and play. We can put the sensor that we want, and this will open up a new way for inspection or without human entry to confined space or working at height. We have a strong use case with Petronas and also Dow, Gasco, and other major operator in oil and gas and petrochemical.
Oke, sedikit tambahan untuk informasi untuk Bapak Ibu ya. Kami sekarang ini mempunyai 4 jenis robotik ya. Jadi yang sebelumnya Mr. Syafiq sudah jelaskan. Yang pertama kita adalah fast RVI ya. Terus yang kedua kita ada PTZ HD30 ya. Terus yang ketiga ini ya Bu, Bapak Ibu ya, ini tipe robotik yang baik ya. Dan yang terakhir adalah brick itu untuk tubing. Jadi bike ini salah satunya dilengkapi oleh 3D lock. Ini adalah untuk membuat simulasi 3D ya dari ininya, dari apa namanya softwarenya. Ya, jadi nanti operator mengetahui adalah pergerakan dari bike-nya, dari robotiknya, dan mengetahui juga lokasinya. Jadi bisa dibuat kita lebih interaktif pada saat kita inspeksi. Oke, continue Syafiq.
Thank you, Rip. So to get this robotic inspection accepted by the customer, we have been performing proof of concept around the world to prove that this inspection meet and exceed the inspection requirements body, such as API or any other standard bodies required by the customers. So one of the POC here took place in Dunkirk. As part of the POC for the bike into the pressure vessel, we perform visual and ultrasonic inspection, and also we show the importance of the 3D localization and mission viewer software, the software that we want to produce the report. By having this ability, the bike inside the asset will help the operator to see in 3D live where the robots are located inside the assets. So this will be a key to a safe and to get a more comprehensive inspection. In this video, you see the inspection bike integrate with 3D log and visual inspection and also UT thickness measurement. The inspector will be using the 3D localization software to navigate during the inspection. And also you will see the path in the 3D image. The other item to notice in the 3D image is the triangles. These are the location points where either visual or UT data or both data are stored in the asset model. During the inspection also, the inspector will record his findings real time for the report preparation after the inspection has been completed. So the air scan UT thickness reading at the area of concern. So the inspection been performed without human entry into confined space. So this will add value to the customers in terms of reducing cost and HSE risk.
Oke, bisa ditambahkan Bapak Ibu semua. Jadi model bike ini sebenarnya adalah robotik, modelnya bisa dipasang susun ya. Jadi dia salah satu basicnya adalah untuk selain RVI, untuk video inspection, bisa juga untuk ultrasonic inspection. Tapi Bapak Ibu bisa juga menambahkan device lainnya, seperti menambahkan boroskop di atas robot ini. Jadi kita bisa mengukur juga untuk 3D profiling pada saat kita mau melihat sesuatu di dalam confined space. Oke, continue, Sophie.
Thank you. So now, the industry, more and more customers validate the use of robotics inspection in order to get a safer and high quality inspection data. So these 3 customers, just a few that have done extensive testing and validation of these technologies on multiple assets. This customer also, they have published use cases that cover a wide variety of applications, from multimodal inspection of vessels, tanks, and also they're using the various navigation and localization software tools that we have developed. For the first case down, we jointly developed the bike with the arm to carry pulse eddy current sensor for corrosion under insulation detection. So the pipe located in big pipe, so to access to let the people in, it's going to be a tedious process. So by having this we can perform or we can check the CUI without human entry. I will play the video how we conduct the CUI inspection with the bike.
Oke, seperti Bapak Ibu lihat ya, di video ini sekarang robotik bisa digabungkan dengan pulse eddy current probe. Jadi di atasnya robotik itu kita berikan device lain seperti pulse eddy current, dan dia bisa membawa masuk probe itu masuk ke dalam kompetitif. Jadi ini robotik ini, jenis robotik ini bisa kita konfigurasikan sesuai dengan kebutuhan kita. Jadi di video ini Bapak bisa lihat ya, Bapak Ibu bisa lihat bahwa ini adalah pulse eddy current. Jadi ada dua device yang terpisah, ya, ada robotik dan pulse eddy current.
Okay, let's go to the next one. With BASF in Germany, at the Antwerp, Belgium, we have done validate of 3D lock system, our GPS, in terms of locating the robots inside the assets. And now they have started to scale up the robotics deployment. Next one with Petronas, we have a strong case in terms of developing the sensors. We have done the corrosion scanning sensors and also the eddy current sensors. So this will help them in terms of to get the corrosion profiling and also for weldment check for crack detection for their weldment inspection. So another sensor that the bike can carry if you have a very small nozzle. So we want to check whether to get the length, width, or depth inside the nozzle. So we will use the bike with boroscope. We integrate with our boroscope. So in this video, we want to check the pitting inside the nozzle to get the size and also the corrosion profile of the pitting.
Recording in progress.
Oke, Bapak Ibu sekalian, jadi sekarang ini adalah robotic bike ini, model bike ini bisa digabungkan dengan boroskop ya. Jadi kita bisa menggabungkan dengan boroskop, dengan probe boroskop bisa mengetahui 3D profiling dari material atau area yang kita mau inspeksi.
Okay. Okay, next robot that we have is Fast RVI. The Fast platform you see pictured here is used to inspect big pressure vessels, big storage tanks, or large spheres. Because of its heavy payload capacity and also its stability, multiple sensor packages can be used as seen in this slide. We're using the 3D lock software and the ability to store the inspection data from the robot's location, along with the PTZ camera position and zoom features, will allow to perform repeatable inspection year over year. So this fast RBI we integrate with the PTZ HD30. So we have 30 times optical zoom to get a clear image if you have a distance below than 6 meters. And also we can attach staining tool on it. So we can adjust what kind of sensor that we want on board. So the next video I will show you how we do the fast RVI inspection, start from the site work, and how we integrate the software tools to perform the vessel inspection up to a report preparation. And before that, the key customers for fast RVI, we have Chevron, Equino, Vertex, because they have large assets to be inspected.
This episode is all hands on. It closes the circle from asset generation over inspection planning to the actual on-site inspection and final report. In this scenario, the fast RVI is deployed through the top manway using a tripod and deployment cage. The complete process does not require human entry in confined space. Also, scaffolding in larger assets is not necessary. The crawler is operated remotely using the integrated touchscreen control station. Thanks to the new 3D localization sensor, the operator knows the exact position of the robot at every point in time. The integration of inspection camera and robot controls leads to a seamless user experience. When taking a picture, the operating software automatically stores the position of the crawler and the exact coordinates of the detail inspected. The 36 time zone and powerful light output of the inspection camera makes it easy to inspect even faraway features. This leads to a great new way of reporting and a tremendous time saving generating a report.
Oke, seperti saya tambahkan juga Bapak Ibu semua ya. Jadi tadi kita sudah melihat video untuk fast RVI. Salah satu teknologi yang kita unggulkan di sini adalah robotik kita itu sudah ada 3D lock teknologi ya. Jadi 3D lock itu bisa membuat kita tahu ya posisi robotik kita ya Bapak Ibu semua. Karena selama ini di lapangan itu kita robotik yang kita pasarkan belum ada 3D lock. Jadi kita masih secara manual. Yang sekarang ini kita sudah update untuk bisa teknologi 3D lock. Jadi kita nggak khawatir akan robotik hilang di dalam confined space atau mungkin kita nggak tahu apakah semuanya bisa diinspeksi semuanya seluruhnya atau tidak ya. Ini adalah teknologi baru dari Waygate Technologies. Oke, continue Safik.
Thank you. Now the PTZ HD30 We call it a robotic camera. It is similar as PTZ camera. Current development, we attach 3D localization to it. So you really see it becoming a more robotic inspection instead of camera inspection. Application for PTZ HD30, if we have a small opening, then we can deploy it through the pole, carbon fiber pole, and mounted on the flange. So to get the full HD image or video into the area that cannot be accessed by human, this PTZ HD30 will do the job. If you take a closer look at the capabilities of the camera, you can see it is a full HD camera. We have very good image. It is 30 times optical zoom. It means you really see all small defects of the other side if you inspect a vessel, and you get a real high resolution of the defects to see what is going on. Even to do with a little bit of measurement, we can switch on two laser dots. It means that the laser dots are displaying two dots on a certain distance. In this distance, you can use for comparison to defects. So you really know these are 1 inch from each other, and therefore you can estimate the size of the defect. The camera can also zoom in, pan, tilt, and turn. Everything is remote controlled. Yeah, as I mentioned before, we integrate this PTZ camera head with the 3D lock pole. So we will have 3D model. So every time the inspector can know where the camera facing, and also we can geotag the defects into the 3D model. All our robotic fleets now equipped with a 3D lock system, so we will help the inspector to locate and to tag the defects in the digital twin. And by having this latest edition of PTZ HD30 with 3D lock pole, it will assist in terms of creating efficiency report and to get the comprehensive data by having all the data stored in the digital twin. So all our robots are controlled using this 22-inch touchscreen control station, or we call it ICS, including the PTZ camera. We added on the pole the PTZ with sensor and collect. This is our 3D localization unit. Then we really can get the data where the camera is being pulled in. I'm going to play the video of the 3D lock. What you can see here is that we made a vessel from the 3D model, and in this vessel, we put the camera in, but because the camera is on a telescopic pole with all the sensor, we really know where the camera looking at is at every single time of the period of inspection. If we see that there is a certain nozzle inside of the vessel, you really see what the camera is looking at. So this is not only good for traceability, but also while you are doing inspection, you get the feeling this is where I'm looking at. The camera is looking at this manway or this nozzle. thus inspection will become more easier, or it will become more clearer. And a very important thing, if we do the same inspection, let's say 4 years later, you really can tell the camera, I want the similar inspection being done. So you get the same photos, the same videos with the same radar output, with the same angle. Then you can compare these videos or these images and see if the corrosion is coming same or become bigger. So the report will become more comprehensive. The good thing about this camera is that it is quite easy to operate. You don't need a very clean or good surface, but of course you must clean the vessel before you do the inspection. Otherwise, the visual inspection is no use. But cases sometimes they need less cleaning of vessel. It also easy to mount on the side of the manway and easy to operate. If you have 100 of vessels in a turnaround time, maybe 50% or more vessel can be inspected using this camera. So you have a good inspection, you have an easy inspection, and you have repeatable and also reliable data. I will start this video. What you will see is that the camera what you see is that the camera is on one hand. On the right screen, you see the live footage of the camera. And on the left side, you will see the 3D model inside of this vessel. So for inspector, it is very clear what he's doing. He knows where to go in this 3D localization. You can also easily take the photos, put your findings with the photo and drop this in the report if you want. The 3D localization together with the mission viewer software and the camera, it really gives you all the hardware and software to do an inspection, but also to do the reporting at the same time. So you can see how clear is the image is. And this camera is located from the defects to the top around 6 meters.
Okay, Sabik, let me add in some information for the customers. So, Bapak Ibu semua, jadi kami punya 3D log pole in software ini selain untuk melihat posisi, juga bisa mengetahui juga ya apa namanya view dari robotik ya. Untuk program ini kita hanya memasukkan drawing dari vessel-vessel atau dari boiler atau dari ini atau material kita ya, nanti softwarenya akan mensimulasikan dan membuat 3D simulasi seperti ini ya. Jadi kita hanya butuh drawing dari material yang Bapak mau inspeksi. Oke, continue Safir.
Now the last but not least, our boiler robotic inspection and cleaning, or we call it brick. Before we move further, we'll take a look at the brick in action. This is a video of our deployment on a chemical plant, water well boiler. You will see the entire cleaning and inspection operation is conducted without human entry. So when you compare a brick to other conventional approach, brick will give you faster, safer, and give better data. Yeah,
Oke, Bapak Ibu semua. Oke, Safik, let me first. Oke, Bapak Ibu semua, jadi ini adalah robot terakhir dari Waygate Technologies, adalah dari brick ya boiler untuk tubing boiler inspections. Nah, ini yang menarik teknologi yang sekarang ini ya untuk boiler ini hanya biasanya kita menggunakan video dan UT ya. Tapi kami sekarang menggabungkan dengan cleaning. Right, Safik, right? So kita menggabungkan cleaning ya dengan UT dan FEI ya dengan visual inspection. Jadi lebih komplit, lebih sempurna hasilnya dan ditambahkan dengan 3D lock teknologi. Oke, go ahead.
Now let's take a look at the brick system. Brick is our largest robot. Some of the key elements here include the swivel magnetic roller drive. These are also the key for its stability to perform 90-degree floor-to-wall transition that you saw demonstrated in the video, including its own weight. The brick has a total payload of 20 kgs. It has also a total 4 cameras on board. The TZ1 HD10, the inspection camera. Then it also has 2 fisheye navigation cameras for front and rear direction. It also includes a prop cam. This is a dedicated camera to monitor placement and operation of ultrasonic probe. As you can see on the screen, between the front rollers, it has the high pressure water jet cleaning unit. This cleans the tubes with a pressure of 500 bar. It also equipped with the 3D localization or 3D lock package and the UT probe module for wall thickness measurement. So this brick can be deployed to the chemical plants, oil and gas, power generation, or pulp and paper. Now, to drive the brick into the boiler, we designed a deployment tool that can be configured for floor entry, which you saw in the video. Depending on the particular boiler design, we may have various access points. For example, we may only have access from burner openings or mainways at the higher levels, and at some level the entry point is too high. It's too high to attempt, so we can adjust or changing the rail that attach to the deployment tool to the curve attachment, as you see on the right. So we can deploy the brick from higher level access point directly onto the side wall, whether it is vertical or horizontal manway opening. Now the NDT part, the UT probe module, the probe movement is remotely controlled and monitored with a dedicated probe cam. So control of the placement of the probe onto the tube was designed to work as much as a manual operator can do. You can move the probe around to gain a better signal up and down, left and right. In other words, you can play around with the probe to get the best coupling and to get the best UT signal response. So each spot measurement gives 3 thickness value at minus 45, 0 degree, plus 45, relative to the 12 o'clock position. So each of these UT data will be stored as an individual A scan. So it will be geotag with the exact position in the digital twin or the 3D model. To bring the robot and the data together is our 3D log system. The operator will see and control the crawler movement live in a 3D space. Each time he captures an image or a UT thickness measurement, that location is recorded. The X, Y, and Z coordinates are also marked in the digital twin. So each of the green markers in the image on the right represents the captured UT thickness reading. The system also can mark the areas that have been cleaned. So the orange line is the recorded path of the mission. This will enable the brick to follow this path again if we have a subsequent missions. Using our RoboSim software together with the digital twin of the assets, we also can design a mission plan in advance before we go to the site, and then we just follow the plan once we in the actual assets. So by having this approach, we allow us to tackle potential problems or challenges that we have at site. For example, how to best avoid obstacles or to plan the most efficient path to complete the inspection or before we actually on site for the inspection. So now the digital twin, the creation of the digital twin of the asset is an important first step in utilizing the 3D log system. We can use any CAD files or drawings to develop 3D model in our asset builder software. Typically, we also perform 3D scan to ensure we have the as-is version versus the design or as-built version using the standard 3D LiDAR system deployed on a pole. So this digital twin is used to guide the operator while performing the inspection as well as record the result of the inspection. By having this, the value of the digital twin is increases over time as we have more vision to be inspected, and then we can also have the ability to return to an exact location or to remeasure a suspect area if we have future inspection. So this will help us to pinpoint again the defects that we have taken before. Here is an example how the workflow is organized for a robotics job. The first step is pretty standard. It's the customer request proposal or information is exchanged regarding a request proposal. And then second step is where we will create digital twin of the asset using asset builder. And then we will develop the RoboSim for mission planning. From that exercise, we will develop the proposal. Then we will use the digital twin and the 3D log to perform the inspection. Another advantage of this report is created as the inspection is being performed, and the report is available upon completion of the inspection. So now, if we compare human inspection and robot inspection, human to let human into confined space, it takes a lot of efforts, lots of procedures, lots of activities where you need to blind, you need to make sure everything is safe, clean, including the procedures. All the blowers need to be there, and manpower need to be ready and aware how to get into confined space. If you have the robots, you need to clean the assets, and you can deploy the robot. So overall, by our customer here, Gasco, they did study on this. They want to minimize the time taken for the inspection, comparison from human to robot, the time reduced by more than 70 hours. So if we save time, of course, we save costs. Okay, I hope you get some insight about how the robotics deployment can help you in terms of assist you in your business pain points. With that, I conclude my presentation. I'll pass over to Rijal. Thank you.
Okay, thanks for sharing with us, Syafiq, dan terima kasih kepada Pak Arif atas penjelasannya juga tadi. Baik, setelah pemaparan dari Syafiq tadi, tentunya Bapak Ibu sekalian sudah bisa membayangkan mengenai solusi apa yang akan kami berikan pada perawatan aset dan inspeksi pada ruang terbatas di tempat Bapak Ibu bekerja. Dan tentunya sudah mulai muncul poin-poin pertanyaan yang kita sudah tampung tadi, dan beberapa sudah dijawab oleh para panelis kami. Dan untuk para penanya yang pertanyaannya belum bisa terjawab, akan kami follow up lebih lanjut dari salesnya masing-masing. Dan sebelum berlanjut ke sesi tanya pembahasan, sesi tanya jawab, ya, kami dari tim panitia memohon kepada Bapak dan Ibu sekalian untuk dapat meluangkan waktu mengisi polling yang akan muncul di layar. Ya, kepada para panelis mohon dibantu. Ya, dan Pak Arif mohon dapat dipandu untuk penjelasannya.
Oke, Bapak Ibu semua, jadi kami punya polling di depan layar Bapak Ibu semua. Kita adakan sedikit pertanyaan ya untuk kita bisa berdiskusi lebih lanjut ya setelah dari webinar ini. Jadi yang pertanyaan pertama mungkin Bapak Ibu bisa melihat ya bahwa apakah di tempat Bapak Ibu semua itu ada fasilitas conference space, karena 4 robotik yang kita hadirkan di sini saat webinar ini kita lebih khusus untuk conference space ya. Tapi bisa juga kemungkinan kalau misalnya Bapak mungkin belum ada conference space, tidak ada conference space, bisa jadi difungsikan untuk di tempat yang lain. Terus pertanyaan nomor 2, jadi ini juga berkaitan dengan sistem robotik yang kami hadirkan, yang kami tawarkan. Apakah dari Bapak Ibu semua memang membutuhkan sistem robotik ini? Karena sekarang ini kita memang lebih cenderung untuk meningkatkan efisiensi ya Bapak Ibu semua. Jadi kita jarang memakai manual lagi, apalagi safety sekarang ini sangat-sangat diutamakan. Jadi kita lebih memfokuskan untuk memakai teknologi tinggi dengan robotik ini. Terus pertanyaan ketiga ya adalah inspeksi yang berkaitan dengan ultrasonik. Jadi robotik kami ini dikhususkan untuk inspection teknologi ya untuk ultrasonik ya. Jadi bukan hanya visual, tapi juga untuk ultrasonik. Jadi kalau misalnya memang ada Bapak Ibu semua membutuhkan ultrasonik, kita juga punya device lain ya, seperti phase array, seperti TFD dan lainnya, termasuk scanner ya. Nanti mungkin bisa kita diskusikan lebih lanjut kalau misalnya Bapak Ibu untuk berkaitan dengan ultrasonik. Sedangkan untuk pertanyaan nomor 4, ya ini juga berkaitan dengan visual. Kita menjaring ya kalau misalnya memang di tempat Bapak Ibu itu sudah menggunakan boroskop Jadi boroskop ini salah satu yang tadi kita tampilkan di presentasi tadi dengan Mas Syafiq, itu bisa ditumpangkan atau disusun sebagai salah satu pembantu dari robotik ya. Jadi mungkin ke depannya kita bisa didiskusikan untuk bisa menambahkan device robotik dan digabungkan dengan boroskop Bapak Ibu semua. Sedangkan yang terakhir, pertanyaan nomor 5, ini mungkin akan lebih khusus lagi, seperti di fase Bapak Ibu menggunakan robotik, nanti kita bisa diskusi yang lebih lanjut. Bisa jadi di tempat Bapak Ibu nggak ada conference space atau tidak membutuhkan robotik atau yang lainnya, tapi membutuhkan teknologi inspeksi lainnya, ya seperti phase array, seperti tubing, ya. Jadi kita dari kami dari Pratita dan dari prinsipal kami dari WG Technologies Baker Hughes itu juga mempunyai divisi R&D Bapak Ibu semua. Jadi kita juga mempunyai salah satu divisi, salah satu bidang untuk bisa meng-create apa yang menjadi solusi dari kebutuhan inspeksi dari di tempat Bapak Ibu semua ya. Jadi tolong dijawab semua ya. Jadi nanti kita bisa kalau memang nanti diperlukan untuk diskusi lebih lanjut nanti kita akan hubungi Bapak Ibu semua. Terima kasih.
Baik, terima kasih kepada Pak Arif atas penjelasan pollingnya. Ya, silakan untuk Bapak Ibu sekalian untuk mengisi polling. Kemudian jika ada pertanyaan lebih lanjut, nanti akan kita bahas. Kita masih punya beberapa waktu. Dan kemudian untuk Syafiq dan Pak Arif bisa diperhatikan ada kendala di Q&A. Jadi ada yang bertanya di bagian chatting-nya. Kalau misalnya.
Ya.
Ya. Oke.
Oke, sedikit informasi buat Bapak Ibu semua untuk pertanyaannya. Ini kita ada 10 pertanyaan yang dipilih ya. Jadi Syafiq, are you watch the questions?
Yep.
Yeah. We have 10 questions can be choose as a door prize winner. Maybe you can choose the ones 10 questions for the winner of the door prize.
So I have here open 8 questions.
Maybe you can choose and you can answer it.
Okay. Okay, the first question, I choose the first question coming from Agus Riyadi.
Okay.
Okay, untuk inspection seperti vessel tank dalam area terbatas, apakah ada pengaruh terhadap internal vessel atau tank yang masih ada sisa fluida, minyak atau air? Okay, to answer your question, I think in every inspection, in order to get the result, to do the inspection, doesn't matter what kind of technique, visual or UT or even eddy current, we need to make sure that the surface is clean as much as possible. And the same goes to robotic inspection. Before we deploy to the site, so we need to clean, if we want to inspect a vessel, we need to clean the vessel. Then we can deploy the robot. And otherwise, if not clean, if we have a deposit, corroded deposit, then it will be attracted to our magnetic wheels because you're using magnetic wheels. So if you have more deposit attracted to magnetic wheels, then it will reduce the magnetic adhesion.
Jelas ya Pak Agus Riyadi. Jadi untuk inspeksinya memang dibutuhkan cleaning sebelumnya ya, agar bisa robotik itu bisa mencekram erat karena dia sistemnya magnetik. Dan ini juga bisa diartikan bahwa robotik ini karena dia magnetik hanya bisa digunakan untuk yang carbon steel ya, untuk ferromagnetic material. Jadi kalau misalnya ada misalnya stainless steel, ini dia nggak bisa, magnet itu nggak bisa berjalan, nggak bisa berfungsi. Okay, Syafiq, anything questions that you want to be answered?
Okay, another question I pick from Muhammad Iwan Wahyudi. Question is, apa aman alat ini digunakan di mana di dalam tangki ada bahan yang mudah terbakar? Apa tidak mengandungi elektrik statik yang dapat menimbulkan short sehingga bisa menimbulkan ledakan? So I believe the question related to 2EX, EX proof or ATEX requirement. So for our robotics fleets, none of our robot is comply with EX standard or ATEX standard. That's why we need to shut down the assets, clean the assets. Sometimes the customer will inject nitrogen with nitrogen purging in order to preserve, to remove the oxygen from the internal assets and do the gas test. If everything okay, then we can deploy the robot. And another thing to consider the voltage. Yep, we use our ICS robot controller. We use 240 single phase AC. So from power plant to the ICS 240, and then we'll convert to 48 DC volt. So I believe some of even in Petronas standard also, any electrical equipment must be below 40 volt if inside confined space. So we comply with the requirement.
Oke, Pak Iwan Wahyudi, ya mudah-mudahan bisa menjelaskan dari pertanyaannya. Oke, number 3, Syafiq.
Number 3 from Agus Riyadi.
Already have.
Okay. He threw 2 questions.
Good questions for
Okay,
the
so,
others. Jadi.
Okay, so we move to the next one.
Okay.
From Bonifacius Aziz. The question is, baik untuk baik akan efektif untuk internal reactor dalam meningkatkan safety dan inspeksi, menurunkan time turnaround dan juga yang untuk tool bagi boiler tube. Mohon next info dan lebih lanjut. Okay. For water wall boiler, our brick is designed for visual, for cleaning, and also for UT thickness measurement. And we believe that by having this, or 3-in-1, so we can totally eliminate human entry into confined space. Yeah, because clean by high water jet pressure, and also take picture using the TZ1 HD, and take UT thickness measurement based on the 3 values at 0, -45, and +45. So we do all together to minimize the downtime, because I believe if we have a boiler shutdown for conventional, for cleaning, especially if it is coal-fired boiler, it takes longer time for the cleaning. By having this, we can somehow reduce the downtime.
Oke, Pak Boni, mudah-mudahan bisa menjelaskan ya, Pak Boni. Terus jika misalnya Pak Boni ingin lebih mengetahui lebih lanjut ya mengenai ini, ya bisa nanti kontak ke salesnya, dan kami siap untuk bisa mengadakan diskusi atau meeting lebih lanjut dengan Bapak. Oke, number 4, Syafiq.
Number 4 from Rico Zaki Zakaria. berapa personil yang dibutuhkan untuk mengoperasikan robot. Okay, for every deployment at site, minimum 2 personnel. One robotic operator, another one NDT operator. So the robotic operator will control the robot at the ICS, the control system, and NDT operator will decide where we want to take the measurement, where we want to take the defects. So it's ideal minimum 2 personnel to be at site.
Okay. Number 5.
Oke, mungkin ini penanya terakhir ya Pak Arif dan Syafiq ya, karena keterbatasan waktu. Mungkin nanti 5-nya lagi kita akan pilih random dari Syafiq dan Pak Arif. Terima kasih.
Okay. Okay, one more. Okay.
Okay.
The last one.
Okay, from Ricky Perdana, the question is, for the PEC and corrosion mapping, will there be 2 different devices involved, the robot and PEC, or corrosion mapping? Okay, this is related to bike. Bike can be equipped with eddy current sensor with the arm. The arm is to hold the eddy current sensor. At the same time, in between the front wheels, we can attach the UT-line scan sensor or the corrosion mapping sensor. So it can be done concurrently. We don't need to use 2 robots to do the 2 tasks concurrently.
Okay, so phase array or the robotic can do it. Okay.
Yep. It's the same like I mentioned with the eddy current. So the pulse eddy current sensor attached with the arm, same goes to phase array sensor. We use arm to hold the sensor.
Oke, Pak Rifki, mudah-mudahan bisa menjawab. Yang jelas sih Pak, robotik yang baik ini dia bisa ditumbangkan dengan beberapa device yang saya yakin juga untuk tadi kita udah ngeliat video ya untuk pulse eddy current, dan untuk radiografi ini juga bisa difungsikan. Cuma memang nanti balik lagi ke arah ini ya Pak, ke arah mungkin ke arah dari kamera untuk radiografi. Ya. Oke, dan Syafiq, kita balik ke silakan. Ya.
Oke, baiklah Bapak Ibu sekalian, we come to end part of session ya. Kami berharap materi yang telah kami sajikan menjadi solusi dan menjadi jawaban terhadap inspeksi dan maintenance aset pada ruang terbatas. Kembali lagi kami ucapkan terima kasih yang sebesar-besarnya kepada para audiens dalam partisipasi hari ini. Kami berharap acara seperti ini akan terus berlanjut dan kita dapat segera bertatap muka kembali untuk melayani kebutuhan NDT di perusahaan Bapak dan Ibu sekalian. Ya. Kemudian untuk pertanyaan yang belum terjawab akan kami follow up oleh tim sales kami di setelah acara kali ini. Nah, akhir kata, saya Rizal mewakili kepada seluruh panelis mengucapkan terima kasih dan undur diri. Assalamualaikum warahmatullahi wabarakatuh.